First AND block was created. Then NOT block was created. Here it is. This version of NOT block was used for NOT block. Then from this one NOT block, there was lots of NOT blocks created into one block. Then OR gate was created. Then there is a code for each bit to produce the table which was described in the coursework, where I used all old blocks which were created previously, all of them, and combining them into one module, LSB. This is the first bit. This is the second bit, using different blocks which I created previously. This is the third bit, and this is the fourth bit. This is overall module, which is collecting all the modules into one and just creating the inputs and outputs. And here is the test bench to test all the circuit. This is how it looks like on the Vivado program. This is overall module containing all the modules for each bit. This is, let's begin from the first bit, LSB. This bit contains all the blocks which are described in the code, and if we click on, for example, AND block, we can see that it was implemented. And actually there is only one AND block written, and it was used many times. The same situation with NOT block and OR blocks. Let's open, for example, this one. This is each NOT block. So this is one NOT module containing 4 NOT blocks. Let's open OR. Oh, sorry. OR. Let's open second bit. Second bit has the same absolutely structure, however with different blocks, because it's different circuit for each bit. So let's open the NOT, which contains all the nodes again. For example, NOT B. It uses, as you can see, it has different names. However, this block was written only once and was used many times for NOT A, NOT B, NOT C, NOT D. This is AND block, just click on any. This is OR block. And all of these were collected into one module to form each bit. Each bit has different number of blocks as it has different circuit. All blocks here. This is the final bit, most significant. Again, the same structure. Let's go to simulation, to test bench firstly. As you can see here, the test bench is written here, the same as shown on the file. Let's simulate it. And the simulation shows that everything is correct. That if you look on the table of desired values from A to D, we will get outputs from B4 to B1, which is totally correct from the truth table which was formed to solve this task. For task 2A, there is code written. There is separate NAND block formed once, NOT block formed once, OR block formed once, There is two versions of GK flip-flop. However, the first version is a bit... Oh, this is, sorry. This is OR block. Give me a second. Okay, again, from the beginning. NAND block, NOT block, OR block, AND block. There is first version of GK flip-flop, which was formed using all the blocks which were created above, using all modules. So this is module which collecting all modules to form one flip-flop. There is a second version of flip-flop, the circuit which is in the coursework in this file. Again, the same structure, we use the same blocks formed previously to form, we just use them many times to form GK flip-flop. Then we have final code which collects all flip-flops into it. And this is the final. This is two codes for two separate GK flip-flop. The problem is none of them worked in Vivado. So this is the first. So I just changed the name. So so the second one has larger F. So it has to be different a bit. And the test bench was written as it was described before. The only bit which has to change is the clock, which just has to shift one to the right. However, it didn't happen. This is the test bench. This is Vivado. So if we open the final circuit, it will contain GK flip-flops for each bit, let's say. So as you can see, all the blocks were used for each bit. This is the LSB, less significant bit. As you can see here, all the blocks were used here. And they are written only once, so they are used many times. For example, AND block. For example, NOT block. For example, NAND block. Let's see the second bit. You see all the blocks which you see here are described here. So if you open NOT, here it is. Here it is. If we open the third bit, let me close this one. Let's open the third bit. Here it is. All modules of blocks which were created previously are used here again, as you can see here. And finally, the most significant bit. As you can see, the same thing here. Let's see if you want to see what is that. This is the blocks which were created. And this is the blocks which were used only in the final code, the final circuit, which is this one. As you can see here, give me a second. Here they are somewhere. As you can see, here they are. However, they used the same block module. Let's see test bench. Again, the clock was changing and the input, logic input, has to be the same. Let's do the simulation. However, as you can see here, the clock was changing and the outputs are showing that the output is forced to be 1 and to be 0 in the same time. That means that the circuit is toggling or self-generating. That means that this software is not able to show the work of GK flip-flop, as the software might not like the feedback loops, which are going from the end of Q in the end of GK flip-flop, which is Q, into the first block. That might be the reason why it doesn't work. Task B2. Again, the same strategy was used here. We form 2 input NAND block. We form 2 input AND gate block module. And we form then, as the circuit contains some blocks which have 3 inputs, so we form 3 inputs NAND block and 3 inputs AND block below there. So as you can see, there is one AND used as it was described in the coursework. This is the way to do it, as the truth table allows that. NOT gate. This is actual flip-flop. This is the final circuit, contains all the modules created before and collected into this module to form the needed circuit and wire all the modules between each other. Then there is test bench written, which should count. Let's see Vivado, where again the final circuit here contains all the modules which were created, all the GK flip-flops wired differently. So if we open it, the NOT gate, so as you can see, one GK flip-flop was used as a T flip-flop, just GK were shorted together to form one input. As you can see, NAND blocks were used in the final code. As you can see, let me expand it. As you can see here, there should be also GK flip-flops which were formed into D flip-flops. As you can see here, all these flip-flops contain different numbers of, this is 3 input NAND, containing 2 input NAND to form 3 input NAND. So this is 8 D flip-flops formed from GK flip-flop, as you can see here. This is not Q gates, as you can see here, were used to create D flip-flops as on the circuit in the coursework. The circuit was described in the coursework. Let's see test bench. So as you can see here, the test bench was written. everything works. Let's do the simulation. As you can see here, again, the same problem as it was previously. The possible reason to that, again, it might not like the feedback loops which are located in GK flip-flops. That's why it might give toggling, or in other words, the output is forced to both states, 1 and 0, in the same time. So the software might not show it. So this is the single RAM was formed for task 3A in data flow modeling. So as you can see here, all gates, well, there is no exact gates, but there is codes for, so this SRAM is just one block. It was formed in one block. There is no need to create node blocks and AND blocks and other things. So it is in one block. This is the test bench to test this single RAM. This is Vivado. Let's open the code. Again, there is only one module, as it's data flow modeling. As you can see here, the same thing here. Let's see the test bench. Let's see the simulation. As you can see here, here is the output of simulation. So for 3B, task 3B, again we're using the same code which was formed in previous task A. This is the SRAM, and this is the coder part of the module. And we created some 4 gate OR gates, 4 input OR gates. That is used in the end of the circuit to collect the bits. Then we create memory, actual memory, which uses each SRAM, which uses module of SRAM 16 times, as you can see here. So this is one horizontal, let's say, word. This is one word, second word, third word, and to continue. There is also fourth word here. And for input gate OR gates, there is 4 of them, OR gates, to collect all the bits. And let's see test bench. Test bench was written in order to test whole circuit. This is the end of the code, yeah. So this is Vivado. Let's click on memory, which is whole circuit, which contains everything. Decoder, SRAMs, OR blocks, everything. As you can see, it has everything here. Let's close this. As you can see here, it contains all SRAMs. This is the 16 SRAMs forwards, and 4 OR blocks, and the decoder part. Let's open the decoder and see which sends the address to each SRAM. For example, open the first word, single SRAM, single RAM, OR gate for input. And let's open the test bench. So this is the test bench, as you can see here. It is pretty wide, so let's, as you can see here, let's do the simulation. So this is how it worked. This is the simulation of whole memory of whole circuit.